Okay, so picking back up, we're going to now look at how we figured out the relative diameter of the moon. So what do we mean by relative? Well, we mean we're not going to necessarily know the actual diameter, but we'll know how big the moon is relative to the Earth or relative to the sun, so some kind of relative diameter. So we have another guy here, Aristarchus of Samos, came up with a plan to find the relative diameter of the moon. What do we mean by that? Well, the diameter compared to the Earth. He used a lunar eclipse and he made the following assumptions. A lunar eclipse happened when the moon passed into Earth's umbra. That's the dark bit of the shadow, right? The sun's rays are parallel, which is a good approximation because the sun's very, very far away, so its light rays do look parallel. And the moon's path took it through the centre of the Earth's umbra, and Earth's umbra had the same diameter as the Earth. So here's a picture. So we can see the Earth moving through the moon moving through the Earth's penumbra, then through the Earth's umbra, back into the penumbra, and out again. So, again we have a ratio here. The diameter of the moon compared to the diameter of the Earth. Now remember, this umbra, we're making the assumption that this umbra is the diameter of the Earth. Now, the diameter of the Earth, if you think about it, the diameter of the moon is effectively how, if you imagine the moon goes from U1 to U2, can you see that the moon has moved approximately one moon diameter? Just think about that for a sec, right? This side of the moon here, the limb of the moon on the left, has moved to here. It's moved approximately one diameter of the moon. The time from U2 to U4, well, if you think about this, moving from U2 to U4 is like moving through the entire umbra. That's the entire diameter of the Earth. So the diameter of the moon is equivalent to U1 to U2. The diameter of Earth is equivalent to U2 to U4. So calculate the diameter of the moon and then tell me which assumption is not correct in this example. So you can pause the video, see if you can work out the diameter of the moon, given that you know the diameter of the Earth, because Eratosthenes worked out the circumference of the Earth and therefore could work out the diameter of the Earth. You could look up the diameter of the Earth if you want, but let's see if you can calculate this. Okay, so assuming you've done that, let's start with which assumption is not correct in the example. Well, we said the moon had to pass directly through the middle of Earth's umbra, and it didn't here, did it? So that's not correct. Calculate the diameter of the moon. Did I ever give that? Well, relatively, it's sort of 0.3 of the Earth, in fact 0.27. Aristarchus calculated somewhere between 0.32 and 0.4 of the Earth. Looks like I don't have a value for the diameter of the moon written here, so you'll need to look one up to see if your calculation was correct. There is a picture to scale of the moon and the Earth. Okay, next up we're going to be looking at the distance to the moon, and that'll come in the next video.